The diagram shows triangle ADC. ADC, that's a big large triangle here. E is a point on AD and B is a point on AC. And it's EB is parallel to DC. You're told that AE is 8, EB is 12, and DC is 15, and you're asked to calculate the length of ED, which is this one here. The first thing to realise is that this large triangle here is an enlargement of this one here. So triangle ADC is an enlargement of triangle AEB. So let's just repeat that again. Triangle ADC is an enlargement of AEB. Now what you do, you need to look at the two triangles and find a corresponding length where you know both of them. So that length there corresponds to this length here on the larger triangle. And that will allow us to find the scale factor of the enlargement. This is known as similar triangles. So the scale factor is equal to this length here, 15, over 12, because we are going to go from the smaller triangle to the larger triangle. If you were going from the larger triangle to the smaller triangle, you'd have to write this as 12 over 15. Right, this cancels down, so we'll cancel it down. 3 goes into 12, 4. 3 goes into 15, 5. So the scale factor is 5 over 4, or you can write that as a decimal, which is 1.25. Now, AD, this length here, is going to be 5 over 4 of length AE, because that's the scale factor of the enlargement, because this length here will increase by 5 over 4. So if we work out 5 over 4 times 8, 4 goes into 8 2 times, and therefore 5 times 2 will be equal to 10 centimetres. So the whole of this length here is 10 centimetres, but we want to find this length here. So in order to do that, ED will be AD minus AE. So AD is 10, which we just calculated, and we told that this is 8, AE is 8, and therefore 10 minus 8 is going to be equal to 2 centimetres. So this has been a video to show you how to find a missing length using similar triangles, but one triangle is drawn inside the other. I hope you've understood, and I thank you very much for watching.